All right, so 1-5 and 1-6, there's an extra practice worksheet. I'm just going to go through these real quick. If you're solving in the indicated domain, so x squared equals 7, and if you solve that, you get x equals plus or minus rad 7. Don't forget the plus or minus. So x will equal negative rad 7 or positive rad 7. Okay? So, but these are not rational numbers. So if we're solving this one over the set of rational numbers, this would be the empty set. You can write the empty set this way, or you can write simply the empty set, or you could even write out the words no solution if you like. Okay. For this one, now we're solving over the domain of irrational numbers. And these are both irrational numbers. Okay. So we can say that that set includes negative rad 7 and positive rad 7. Okay. This one over here, we're going to set this, and we want the answers that are positive numbers. Zero product property with a product equal to 0. So either x plus 3 is equal to 0, or 3x minus 2 is equal to 0. So here we get x equals negative 3, and we get 3x equals 2, or x equals 2/3. We only want the positive numbers. That rolls out the negative 3. So we get x is equal to 2/3. Or in set notation, you could just do the set that only includes 2/3. Okay. Next one, x squared equals 1/9. So x equals plus or minus the square root of 1/9, which is 1/3. Well, neither of those are integers. So we're going to have empty set again. Empty set. Or you could write empty set. Okay. Next one, absolute value of x is equal to -9. This is a little tricky. If you're not thinking, you might miss this one. Okay. When you take an absolute value of a number, you never get a negative. Okay. This is not possible with a set of real numbers. Okay. So you get empty set. Or you could say not possible. Okay. Next one, 5x plus 3 equal 2. Split that up into 5x plus 3 is equal to 2, or 5x plus 3 is equal to -2. 5x is equal to -1. X is equal to -1/5. 5x is equal to -5, so x equals -1. So your set is going to include -1/5 and -1. Okay. Next one, notice we're solving over the set of integers. So we get 3x is less than, adding 5 to both sides, 9. X is less than 3. Okay. So we're going to include, let's write this in set notation. We could say everything, all integers less than -3. So -3, -2, -1, 0, 1, 2, 3. That's fine. You could show that. Oh, don't include the 3. Sorry about that. 0, 1, 2. Stop there. You just want the integers that are less than 3. Okay. Then you can show that that goes on this way. If you want to do set notation, set of all x such that x is less than 3 and x is an element of the set of integers. Okay. Finally, we want positive numbers. 2x plus 3 is less than or equal to 10. So 2x plus 3 less than or equal to 10. 2x plus 3 greater than or equal to -10. 2x less than or equal to 7. X less than or equal to 7/2, so 3.5. So 2x is greater than or equal to -13, or x is greater than or equal to -13/2, or -6.5. Okay, so this we're going to write set notation, set of all x positive numbers only. So if we think about this on a number line, let's look at it. Less than 0, 1, 2, 1, 2, 3, 4. So we want less than or equal to 3.5. Go that way. Greater than or equal to. So normally we would just use all these numbers, but since we want positives only, we're going to cut out all the negatives. And we just want the numbers between 0. Actually, don't include the 0. That's not positive. Set about x such that x is between 0 and positive 3. You can't include the 3. Okay. Or you could write the interval from 0 to 3. So that's another way you could write it. All right.